just bring you the idea of those. And then I will shortly discuss the semantic knowledge base as a project and come into the extended semantic networks module. And at the end, I will show you an example. So at first, the semantic networks were introduced more or less in late 60s by Collins and Quillen. They were called teachable language comprehender, and what they said was that there are three most important concepts: units, properties, and links that connect them. This is very simple structure, and somehow it can, let's say, code any kind of information, but they do not have semantics for themselves, since it's hidden into the units and properties, the names of them. It's just the structure, the graph structure. Not long ago, they say, Collins especially said that it's not enough, and they added some few notions. First of all, negative links that were missing, and the strength to the links, so they can compare them between each other. What is interesting, the idea of semantic networks was somehow extended in late 70s by Hendricks, who said that there is a need for so-called partitioned semantic networks. So putting some part of information into a bag and just referring to this bag as an information storage. But still, it's its own like drawing on paper and saying that there is something. It was still a graph. It was, let's say, partitioned graph, but still no semantics in it. What we decided to do when we started to work on the semantic knowledge base was that we need to supply some semantics into semantic networks to use them. So we decided to use ontology, and we've also developed some more modules, especially linguistic module for communication with the base, and dimension and spaces module, which provides us the possibility to use some theories like possible word theory by cryptkeys. The system is pretty simple. It has the ontological module in the center that consists of ontological core where we store concepts, and structural module for coding the information, how the concepts are connected with each other. Then we have the linguistic module, like the interface module for the system. And the most important today, the semantic networks, which we use for the storage of facts and rules. I don't want to bore you with the semantics knowledge base construction at all, but what I want to say is that the ontological core has the ability to store information about concepts that are divided into most important classes. And what is important, it has only the definition and attributes for concepts. So we can say that there's a car, it has some property like color, and we can set the color in here, but it's pretty hard to, for example, store the information that the car is driving, can be driven or something like that. It's rather used by the structure model. And this is the semantic networks module. The most important thing is that we use concept as a base for operators, and operands. So we have simple nodes, like the operator connects with operands. We build the networks, and then we extend it with some ideas like multiplicity, quantifiers, or modifiers. So the operator, it holds the node the biggest node in the semantic networks. So the structure of the networks that we use is more or less like hypergraph. We have two different types of nodes. The first one, the first level is here we have operator and operands, and then we can go deeper to go into the concepts. Each operand and operator has its role. So for example, if we have the operator go, it's an activity. Then we have three operands connected to this node: John, New York, and car, and each of them has its own predefined role assigned. So simply saying what we've done with semantic networks. We added modifiers. So for example, a big car in a sentence, that's the big is modifying a car. We've added quantifiers, time quantifier, space quantifier. We said that there is a need for multiplicity. So for example, saying that the car has 4 wheels, it wasn't possible to do it before. And the certainty factor. So what we have here, first of all, time and space quantifier. If we discuss the sentence that John goes to New York by big car and he's going very fast. At the end, I will show you how this sentence looks like written in more or less proper English, I mean in linear form. This is just the representation of information that an actor who is John, and we are not very sure if it's John, to be honest, goes to New York. And we don't know how often he does that. I would say not very often. What we are sure, he goes very fast if he does. And then he uses a tool which is a car. And we are pretty sure that he is using the car. And this car is big, if it's used anyways. So on this slide here you can see that we use the quantifiers about the New York and the car, and the certainty factor, but I'm not going to discuss it right here. And we can add multiplicity to this. So for example, we can say that he's going with passengers, and probably there are 3 or 4. So he can take 3, but maybe he's going with 4 passengers, who knows, but not less than 3. And once again, the structure, where we use it. If we talk about multiplicity, it can be assigned only to operands, because there is no need to say that 2 or 3 times going somewhere. I mean, it wouldn't make any sense to add multiplicity to operator. So we use it only on operands. If we think about quantifiers, it's more complicated, because we can use it both on operators and on modifiers, as well as on operands. So we can use it on every single element that builds the network. So we can say that every element can have time, space, quantifiers defined, as well as intensity quantifier, but it's not very important right now. And this is how the information looks like stored in the base. If you let me, I won't discuss it very deeply. I'm just saying that the pictures that I showed before were more or less like conceptual. These are physical representation of the information stored in a semantic knowledge base. And this is more or less the information that the last graph was showing. So we have that the probability that John goes with 3 to 4 passengers pretty fast, but not very often to New York City, but probably big car, and this big is like everywhere. I mean, it's quite hard to put this information into sentences. I should split them into few sentences and join them by any operator, like logical operator, and show it. But the idea of showing this sentence in this form was to show that the expression of graphs is much higher than the expression of linear sentence. So, to summarize, we've designed the semantic knowledge base. It was showed on a few conferences, and right now we are supplementing it with data. It's not a very simple process. I mean, we strive from automatic supplementation. We rather do it manually or semi-manually. We've designed the semantic knowledge, semantic network module that I showed you today. We are still working on it, trying to find the best solutions to find what we can do and what we cannot do. I wasn't showing you that. I'm using the time that I have. And I can say that we implemented the partitioned semantic networks in this module. We've done also some other things to make it easier to use. And right now we are also working on inference algorithms that would scan the networks and try to extract some information and let's say make this whole base more interactive. And I guess that's all. Thank you.
Are there any questions for our speaker?
Yeah. Maybe it's not a question, but comment. Could you please go back to the diagram of your semantic network?
Where exactly?
The diagram is yeah, this one, for example. I think it's better to use additional nodes, for example, between car and big, because it's not a direct connection between car and big, but the car has size and size is big. It's a kind of pattern of parameter value.
Mm-hmm. Yeah, if I use it, as you said, on this picture, it would be much bigger and it would be, let's say, a little bit harder to show it. But I will just go a little bit right here. If we talk about it, we have the concept, it's abstract. The car would be the class or an instance, whichever of these. And then you have the feature, which would be the size. And you have property and value. So size and big would be connected here. So you can find the connection either in here or we can use modifiers right here. So we can say that there is a car, make the connection with the feature size and connect the value big. So this is designed this way, but for the purpose of simplicity of this presentation, it was showed this way.
Are there any other questions? So I also had a comment. So in my talk, I talked about this three-part statement.
Mm-hmm.
And I think this is your version of my three-part statement, which is much, much richer. But then I think, oh, how on earth could we deal with this in this type of environment? But maybe I should look at this. And also, one of the reasons I'm interested in video is because we don't have this problem with the language generation, that we're more forgiving with video. So we could somehow use that as descriptions of the video and then use that to do this video assembly process. So thank you very much. Any more questions for our speaker? Otherwise, we have an extremely long coffee break. So I would say go out, enjoy the sun and come back for the next session. Thank you very much.